Okay, the last thing we're looking at is how we can tell by looking at an equation that something is odd, even, or neither. So here is 3 graphs. One's odd, one's even, one's neither. So if I look here, this one is flipped over the y-axis, which makes this one even. This one would be the same if I flip it around the origin. So this one is odd. And then this one, if I flip it around the origin, it's not the same. So that's why it's neither. If I flipped it around this point, if I like spun it around that point, then it would be the same, but it has to be around the origin. So this is neither. So then looking at the equations, if this one is even, we can look at the equation and see that these two exponents are even. This is odd. And if we look at the exponents in this one, they're both odd because technically there's a 1 here. And then this is neither because when I look at the exponents, this one's odd, but this one's even. So just by looking at the equations, we can tell if they're even or odd because we look at the exponents. So the definitions are here. An even function, if we're looking at the equations, have all even exponents. We're looking at the equations for odd, all equations have odd exponents. And then obviously if it's a mix of even and odd, then it's neither. All right, so then on the next page, what we practiced on page 325 was we looked at this and we decided if it was even, odd, or neither. So looking at number 1, 4, and 2 are both even, that makes this even. When I look at number 2, 3, and this is technically a 1, both of those are odd, so this is odd. Now when we get to number 3, we actually need to kind of do the math for this. So we actually need to do the box and decide if the exponents are odd or even. Now really, I don't care about the constants or I don't care about the coefficients. I just care about the exponents. So even though this is really a 1 and this is really a -4, I don't really care that much about it. All I care about is that this is going to become an x to the 4th. This is going to become an x squared. I don't really care what the number is in front of it. And this is going to become an x squared. And again, I don't really care what number is in front of it. And this one I don't care at all because it doesn't have an exponent. So these are all even exponents. So that's going to give me an even here. So it's important that you actually do the math because if you look at number 5 and we look at the exponents to begin with, this is a 3 and this is technically a 1, which is what is going to make us think that it's odd. But we have to do the math out for it, which means we have to distribute this x to the x to the 3rd and to the 1. And when I do that, I get x to the 4th minus x. Now I have an even exponent and technically an odd exponent. So this one is neither. Right? So you have to do the math. Right, number 8 is almost the exact same thing as number 3. They just changed what the constants were. So it doesn't change the fact that it still ends up being even because we get an x to the 4th and an x squared. Now 9 and 10 look a little confusing because it's 1 over x. We should remember that whenever we have a fraction, that means our exponent must have been a negative. So this could really be written as x to the -1 plus x. Which technically is a 1 too. So even though this is negative, it's still odd. And this is still odd. So this is an odd function. And basically this is the same thing because it's still x to the -1 and now it's minus x to the 1st power. But again, it's still the same thing because we're only looking at the exponents. I don't care if it's plus or minus in between. So this one is also an odd. Right? So that's how you can tell by looking at an equation.